Hi, everyone, and thank you for joining me for today's episode in Caserta's Data Intelligence webinar series. I'm your host, Remy Rosenbaum. Today, we're going to explore the topic of cloud native architecture and how it fuels business growth. I've heard from a number of our clients that the business side order to move to the cloud, and typically that's without any guidance or information about what that really means, and pretty much built around the hype of being in the cloud. But what does being in the cloud really mean? Some companies get it right, like when the New York Times came to Caserta for data strategy guidance after being handed down a mandate from above to shut down their on prem data centers for good. Instead of a lift and shift of all their data to the cloud, we helped the New York Times re architect all of their disparate silos into one flexible, scalable, robust cloud native architecture on Google Cloud. And now they're able to take advantage of all the services that GCP has to offer. Their new architecture unlocks innovation to fuel business growth. Aside from new analytics capabilities that have enabled them to increase sales and reduce churn, the Times is now able to offer personalized content and experiences at a level previously unseen. Some of our clients that already have their data in the cloud have come to us disillusioned. They've felt that the promise of the cloud to fuel business growth did not deliver. In some cases, as with United States Insurance Company, data had been migrated to the cloud, but with some minor re-architecting. But with the business goals were never truly understood, and that's a missed opportunity. So we came in and we talked to the stakeholders to understand what goals they're actually trying to achieve, and then delivered an actionable data strategy that detailed the steps they need to take and the architecture required to get there. For that client, we ultimately implemented the data engineering strategy as well. In today's episode, Caserta principal consultant Bryce Giesbrecht is going to explore cloud architecture considerations as well as innovation opportunities. Bryce has developed solutions across many industries, small and large organizations, from startups to the federal government. And for the past decade, Bryce has been focused on data-intensive areas, including large-scale data processing, big data, Internet of Things, and all things analytics. Caserta's complimentary data analytics expert webinar series is designed to give you insight into today's hottest technological trends and issues. After the webinar, I encourage you to speak with us about any questions on how to apply what you've learned today at your organization. Of course, our initial consultations are always free, and if we find an opportunity to work together, whether on an assessment, a validation, or an implementation job, then we can discuss the next steps. And if not, we will gladly point you in the right direction. After the webinar, we'll send you a recording to the email address you provided. And if you have any questions throughout the presentation, I beg you, please enter them in the questions panel on the right, and we'll answer them during the live Q&A session at the end of the webinar. Bryce, the stage is all yours.
Thank you very much, Remy. Appreciate it. Let me go ahead and excellent. So thank you everyone for joining. There are many aspects that we're going to cover in this webinar. Obviously, we're going to start off with our fun slide here. Just say no to lift and shift. So I have on here a couple points, but I'd like to talk about what lift and shift is, just to make sure we're all on the same page. So lift and shift is when an organization will try to essentially duplicate their infrastructure as they currently have it in the cloud. So if they have a set of servers that perform certain tasks and house certain data and are connected a certain way, they will essentially duplicate that in the cloud. And so that is what I'm referring to when I say lift and shift. So we're saying that we should say no to this. But let's explore, first of all, why that is actually done in the first place. Well, one of the biggest reasons is that it is a short path. It requires no real re-engineering of your current infrastructure. You already have your architecture, it's laid out, it may or may not be documented, but you can certainly find out what it is and then duplicate that in a cloud environment. So it is often perceived as the easiest and or the quickest route to the cloud. And is that true? Yeah, if you do that, you will be in the cloud. But one of the reasons that someone may do that is perhaps the benefits of the cloud and the infrastructure that is afforded, the different paradigms that exist within cloud processing are not fully realized. And it has been reduced, the cloud that is, to a virtual or invisible data center. Instead of having all of your servers, all of your processes, all of your systems in a data center down the street or in a couple states over for DR purposes, now we just have them a little further away, somewhere where we can't actually drive there and see them. That is often, maybe perhaps, I see one of the biggest understandings of the cloud, which I actually consider to be a great misunderstanding. Perhaps other options about using the cloud are not known. The only option may seem to be lift and shift, because that's obviously what we have. That's what we're starting with. So one of the points I wanted to follow on to that is how this can be problematic. Obviously, we're saying no to this for a reason. Lift and shift may not be able to facilitate all of your platform if you attempt to set out that way. You might run into some gotchas down the road. You might end up only moving in a lift and shift capacity some of your infrastructure, and then you're left with this situation where your IT team, your business, your customers possibly have to live with sort of straddling this hybrid solution, which may not be optimal in any way. One of the other reasons that it can be problematic is the exact opposite. Maybe you're actually too able to move your entire system, your solutions, your processes into the cloud seemingly without any issue. That actually can be a problem, because there are many adages that I like to govern my work and my philosophy with. One of them is the right tool for the right job. And honestly, some hammers, if you see everything as a nail and you pick up a hammer, some hammers can be quite expensive to use. And if you are not using components in the cloud in the way they were designed to be used, but you're using them in the way that you have used a similar component out of the cloud, you may run into some billing shock later on. It may not be the most efficient way to get the work done. And so that is kind of the theme of this webinar, is basically tapping into what is a cloud way of architecting your business, your data solutions, your processes, etc. How do we go about doing that? So I did want to address the last point on this, which is this principle of just say no to lift and shift, is it ever untrue? Is there ever a case when you want to do lift and shift? Well, I think that the short answer is no, it is never untrue. Because lift and shift has this connotation to me that your approach lacks awareness of the benefits and the true differentiating paradigms that exist in the cloud. So to embrace the lift and shift mentality, to me, would indicate that perhaps a lot of these things haven't been fully understood or haven't been explored. And so it's my hope that through this presentation that we will fuel the fires of discovery toward this end. So general considerations. Before we start, I wanted to do a little bit of housekeeping here. While I have experience with many cloud platforms, for this presentation, I'm going to use generic terminology. And when I do not use generic terminology, I'm going to use Google Cloud Platform specific terminology. So if we're going to have to pick a target cloud, I'm going to select GCP. I'll also use the terms solution, platform, system, maybe even architecture synonymously. I've actually already done that in this presentation. So I want to make sure that I'm not connoting specific things to this. I mean these terms to represent your general processing infrastructure and data processes, systems, etc. So when considering a cloud approach, I'd like to talk about, these are some general topics to consider. How the cloud is different than what you're currently using in your non-cloud situation. Now, there may actually be some situations where you are approaching a cloud-like setup, a cloud-like awareness outside of the cloud. And we'll talk about that towards the end here with containers and microservices. But first, I'd like to talk about security. And so I would like to say that I am making generalizations based on my experience for the last couple decades working with, as Remy pointed out, customers from large and small. And so everyone's company is different. They have made different choices. They have different cultures. I do not hope to be oversimplifying or being too reductionist in my thoughts and thinking here in my speech, but I would like to essentially pick a target in our minds that we can kind of converse around. So we're going to talk about security here in the view of a Acme company. So Acme companies view security, who are not on the cloud. When we talk about security, there's different aspects: network, accounts, OS, application security. Network security is really big. It's a very important topic. And most companies who are not in the cloud, they usually take a multifaceted approach to security when it comes to their network. They usually have perimeter security, big beefy protections around entry points into their system, with firewalls, DMZs, other types of infrastructure to protect their systems from unauthorized access. In addition to this, internally inside the network, the systems that make up the overall architecture, they usually run on, they have their own accounts. They run on different operating systems. They have maybe integration with some sort of a directory service like an Active Directory or some other LDAP implementation. In addition to this, you have OS security concerns to think about, virus scanners, things of that nature. And then on top of that, we have application security. The apps that are actually deployed themselves are being used by end users outside of your environment. What kind of trapdoors, what kind of issues lay within those? We're not going to talk too much about application security in this, but I would like to get you to start thinking about how would the cloud address some of these things. Google Cloud specifically has their own software-defined network, which allows great flexibility in securing your infrastructure. For one example of thinking about security and how it relates differently to the cloud. Backups is another great example. A lot of companies, most companies, I would dare say, I'd love to say all companies, but I know that's not true, but most companies have some sort of backup policy in place. I remember the days of changing out tapes and tape drives and robots and all that great stuff. We've come a way since then, thanks to storage technologies have increased so much and improved. But backups, a non-cloud solution has a particular flavor of a backup strategy. Moving to the cloud, that backup strategy is going to have to be reevaluated. Not because backups that aren't done in the cloud, it's that thinking about your data and the persisted nature of your data in the cloud changes your view of backups, and that's actually a good thing. One of the big words I hope we're not all going to get sick of during this presentation is scalability. Scalability is really important to me. This is one of the greatest advantages that the cloud brings. Most of the examples that we're going to talk about later in this presentation revolve around improving scalability. Obviously, this is a topic, this webinar is about growth. And in order to enable growth, enabling your infrastructure to get larger without sacrificing performance, throughput, security, etc., is crucial. If your business is growing, but your infrastructure cannot, you are in a very bad spot. And so the good news is you don't have to be in that spot. So towards that end, microservices have really become popular topics of conversation in the past couple of years, as have containers. Microservices are more a way of decomposing business processes into standalone units of execution that can be deployed, completely isolated from everything else, as far as their ability to scale up and down without having to scale a server up and down, which contains many other processes. You can think of them as totally contained processes that are running, and can interact with other processes as dictated by the architecture. The containers, Docker, Kubernetes, they're some of the big names that are in great demand. Those types of approaches have really revolutionized and enabled great growth and scalability options in the cloud. Containers allow you to think of them as a virtual machine that is minus the machine. So you have these containers which encapsulate your running code, and they can be portable, and the machine itself is abstracted away. So they allow for great growth, duplication or clustering, things of that nature. So the cloud thrives on these last 3 points: scalability, microservices, and containers. But if your infrastructure is not in the cloud, scalability is handled differently, right? It is handled very manually. You scale up, you scale by adding more servers, you scale by adding larger servers. In the cloud, those concerns are abstracted away. They can be largely abstracted away. So while we were talking about specific things about that you should evaluate when preparing to re-architect for the cloud, these concerns, these specific considerations are more about how your infrastructure can change, as opposed to how the cloud is different. This is more about how your application can be different, should be different. So the first 2 points, data movement and processing are tightly linked together, but they are not the same. As we mentioned, scalability is a huge boon to consumers of the cloud. And to that end, data movement allows, because we have these processes at our disposal, data movement is just that. It is moving data from point A to point B. And if you have a linear system or a linear data solution, right now, when you go from step to step to step to move your data through, to enrich it, to do various tasks, to put it in different areas for different purposes, that's what we're considering data movement here. Processing are the actual methods, the business transformations that take place on the data itself to provide better value. And these two go hand in hand. In the cloud, data movement and data processing has been made very, very flexible as well as scalable. So as mentioned, the right tool for the right job, there are many different opportunities available for data movement. And the reason this is something for consideration is that data movement within the cloud is one of the avenues of revenue for cloud providers. And so your data movement needs to be thought through. It needs to be analyzed from a business standpoint, but also from an architecture standpoint, to make sure that your data isn't being moved unnecessarily. And if it is being moved unnecessarily, that could be a symptom that your actual architecture may not be optimal, regardless of if you're in the cloud or not. One of the, as an aside, one of the things that I've noticed while re-architecting companies' systems is that it is a natural outgrowth of that is a cleansing, if you will, a purification of data processes. Things are caught as unnecessary, or they could be recombined to make greater efficiencies. So data movement, data processing together go hand in hand. An example of that is ingest. So if you have if your organization intakes data of some sort, you're ingesting data. And so the main point around data ingest is that it can be handled with great flexibility in the cloud, whereas outside the cloud, I've usually seen solutions that have resorted to cobbling different systems together. And with the ingest capabilities that exist and the different variety of implementation choices, you can pick an overall ingest landing zone, if you will, entry point into your system that offers maximum flexibility and promotes more of a homogeneous processing thought pattern within your architecture. Another aspect of specific considerations is logging. Often when you have a traditional enterprise architecture, logging is not centralized. Obviously, we have things that popped up. Everyone has probably heard of Splunk. That started out as a logger unification framework. Why did that exist? Because the need existed. Why did the need exist? Because, as Remy pointed out earlier, we have disparate systems, right? We have disparate systems doing different things, but we need a way to see across the enterprise what they are doing. Logging is quite difficult in a traditional enterprise system when you have very heterogeneous infrastructure with different OSs and different processing paradigms. Correlating those logs together in a meaningful way while being able to keep the noise to a minimum can be quite difficult, especially if you're using different logging frameworks across different systems because you're using different languages or different tools from different vendors. The situation can be quite complex. In the cloud, even though it is the cloud, you think big, wide, open processing infrastructure, in particular GCP, logging is actually quite a joy to work with. Logging is unified. It is available as a single pane of glass across all of your infrastructure. So that is a big difference that I wanted to point out between a cloud architecture and a non-cloud architecture to accomplish the same business goals. Lastly, I wanted to discuss billing. Billing is obviously very important. If we're going to grow, if our businesses are gearing up to be more successful, obviously we want to make sure that we are not spending more money than we need to. Billing differences between the cloud and non-cloud architectures should be considered quite carefully. One of the reasons for this webinar is to hopefully promote a way of thinking about setting up your architecture, defining your processes, defining and creating your data processing, your pipelines, etc., in a cloud native way to leverage the cloud the way it works well. And when you do not fight the cloud does not fight you. And so this actually comes through quite a bit with billing. If you find yourself doing things the non-cloud way, your billing will actually reflect that. So it is a metric of how you are doing in adapting or re-architecting your business in the cloud. So as we've talked about specific general recommendations and then specific recommendations, as we're considering our enterprise moving to the cloud, I wanted to throw in some ideas that can come up. I talked about the process of distilling or purifying your architecture. These are some, we're not going to discuss all of them. I wanted them here mainly for reference, but the cloud provides, and we're, like I said, GCP specifically, native support for object versioning. That is not necessarily a common non-cloud paradigm. People can do versioning. Obviously, we have version control of things. There are systems that do allow you to version objects through their APIs, etc. But object versioning with your storage, with your directories, that's kind of that is a great opportunity to really streamline our processing pipelines. So object versioning allows you to store a file. Let's say you have a file of names.dat, and you get another file that comes along and you put it in the same directory or the same bucket, names.dat. That doesn't necessarily mean that the first file has been replaced. You can enable versioning, and now you have a history of how this file has changed over time. This leads to great opportunities for auditing, compliance, as well as analytics around how your data internally and the data itself, what it represents, is changing. Those are important data points in any large infrastructure. Lifecycle management of objects also promotes a clean environment. How often have we talked about we have dead wood in our infrastructure? We have stuff that is no longer used, and no one knows what it does. No one knows why it's still there, and we're afraid to remove it because we don't know. Well, lifecycle management coupled with the lifecycle management policy can enable people to architect a solution up front, lay down some principles, and allow the system to do its job automatically. So for instance, if you are moving data through your pipeline or moving data through your environment, you can set up processes to take place when an object is updated, or if an object is deleted, or if an object is added. Background processes or other types of execution can occur at these critical points in the life cycle of an object. Those are natively built in to many components in cloud infrastructures. So speaking of infrastructure, IAC is a burgeoning topic as well. Infrastructure as code is the idea that you can script your environment creation. Now that in itself is not new. For years and years, decades even, admins write scripts to build up environments. However, infrastructure as a code has this really incredible ability to not only create and tear down, but manage infrastructure. So if you create an infrastructure, let's say you're setting up multiple storage units, think drives or storage buckets, some processing engines over here, a message queue over here, and you say, this is my network, or my architecture, rather, I have defined it here in this file. You can periodically check your infrastructure to see if it actually matches how you defined it. And if not, take action on that. This is a great way to keep compliance, change control, right there as a tool to prevent you from using your architecture as intended, but also to prevent costly mistakes, perhaps, by someone deploying something and then forgetting about it, and maybe even more nefarious activities, such as a malicious server has been set up and it's flying under the radar. Infrastructure's code allows you to do this, to catch those types of things and manage that, take appropriate action. One of the great things about infrastructure's code is you can version these. You store them in your source control. You can use these to stand up new environments quite easily. So let's jump down to deployment environments. Using IAC in the cloud will allow you to actually set up, if you don't currently have deployment environments, such as a dev environment and a test environment, a QA environment, stage, prod 2, etc. Having IAC allows you to quickly stand those up and have them look almost identical to another environment, because you're using the same infrastructure, because the code has defined what that infrastructure is. And when I say code, think more of like configurations in a file, YAML, things of that nature. So we're going to talk about integration a little bit later on, analytics as well. So these are opportunities for innovation as you're considering moving to the cloud. These are things that the cloud natively provides, and or if it doesn't natively provide it, it allows it to occur at a very low level. So one of the aspects of thinking about moving to the cloud, re-architecting your current infrastructure, is how to fully utilize the cloud and all the benefits thereof. So on the left-hand side, we see usage patterns of specific purposes within the cloud. If you start at the very bottom, we talked earlier about our ingest. We have a landing zone per se. This is where your data comes in. We have the ability to move that through various environments for various purposes. Here we see a data lake, data science workshop, big data warehouse. As you can see, that data is being honed and used for more increasingly specified purposes. On the right-hand side of the slide, we have actual data governance policies that can, with ILM, information lifecycle management, to govern the data, how it's being used, who can change it, etc. These are quite important when you have a large amounts of data, and using the cloud can indeed promote that. It doesn't mean that every company that has a solution in the cloud is going to have untold petabytes of data. Back in the day when I was doing quite a bit of big data work on Hadoop, a common myth that I would like to talk about is big data doesn't mean you have to have a lot of data. A lot of the benefits of big data are translated directly into the cloud, because what it does is it challenges your existing thoughts. It challenges your paradigm. So the ability to rethink your process outside of the box. Ask not, well, what are we doing and how can we keep that running? And instead ask, what can we do? What opportunities are afforded us through these new advancements in technology? Those are the right questions to ask. And having data governance in place can protect you from not only having dead wood, but from maximizing the value of your data, especially when it comes to larger corporates with security concerns, HIPAA, et cetera, all that good stuff. So I wanted to talk about a specific client example. This is going to be an actual Caserta customer. We're going to briefly review non-cloud infrastructure and give an example of some of the things we've been talking about. This is a large international food company. You would know them. Their situation is a common one, and that's why I chose this particular example, is because it is, I believe, a very common situation that will probably resonate with many folks. So what we have here is we have just a simple architecture, more of a data flow diagram. We are ingesting point of sale data into our architecture. We've got a couple stores, and they're doing fine. They're sending us their point of sale data in a batch mode, uploads to our environment periodically, let's just say daily, and via NFS we kick off a move and a load of that data from our hard disks into our database, and then we transform that, and then we run other transformations on that and load them into specific data marts, all driven by our enterprise scheduler. And it's working great. We onboard some more points of sale systems, more stores are popping up, our business is growing. It's great news. Everything is going really, really well. And then all of a sudden it's going really well. And all of a sudden our infrastructure can't necessarily handle all of this data being pushed through our system. Our storage is saturated. Our jobs aren't able to complete on time. Our reports that are sent to our executive teams and leadership are now taking, instead of 3 hours to complete, they're taking 13 hours to complete. And the accuracy of the results are in question because of the latency of the processing. This is exactly what was happening to this customer. And even though I'm thinking of a specific customer, I've seen this across several customers. Whether your data is coming in from a point of sale system, or it's coming in from a government mainframe, or if it's coming in from a clickstream source, etc. This is a very common paradigm of ingesting data, processing it, storing it, making it available to other sources. A cloud solution that can follow this is as follows. One of the things to notice is, obviously I'm using GCP terminology icons here, but this is the exact same, this is accomplishing the exact same business needs using specific cloud technologies. And it not only meets those needs, it has provided extensibility as well as being obviously scalable because it is running in the cloud. So our data is coming into cloud storage. Cloud storage in GCP is incredibly scalable and durable depending on your storage class. As it comes into cloud storage, instead of having a scheduler kick things off every 5 minutes or having to bump it up to every 15 minutes because it's just not getting done in time, you can easily transform your system into an event-driven solution. As using object lifecycle management, as we talked about earlier, as data comes in, lands in our landing zone, we can instantly handle those files that have arrived in near real time, have them processed in a streaming manner through data flow or a data processing pipeline, and then pushed out to BigQuery for analytics. Think our data warehouse, or pushed into Cloud SQL. Think smaller, data marts or relational databases that drive user interfaces or other applications. In addition, we can load that data back into another bucket, into another cloud storage in a format that's suitable for consumption by specific machine learning frameworks or analytics teams, etc. Our processing pipeline can admit all of those. And the good thing about this is this scales. This scales to meet the needs of our business. Client example number 2. This is another Caserta client. Essentially the same points here. I've added in here multi-project integration, although that's not really visible on the slide here. But this is an example of a company that was re-architecting for growth. They had some needs. Scalability is a big one, right? Their platform had evolved for many years, which met their needs. It met the needs at the time. But they, like our previous client, and notice the pattern here, growth, they were experiencing success, and we want that. They realized that they could not scale their platform to meet the growth and the processing needs of their business. So in addition, opportunities for innovation, we talked about some of those opportunities before, they were stifled. The architecture that was in place was inflexible, and the architecture that was in place was actually very expensive. So not only was it costly, it was costing them more than just that outlay. So after partnering with Caserta, we developed an architecture, we proposed it, and subsequently put it into the cloud, which not only provided the desired scalability, but it also facilitated flexibility with robust processing pipelines. These leverage the cloud storage we talked about, microservices, the unified logging, greater security controls. Additionally, data was enriched with proprietary as well as shared data, public data. The new architecture opened up opportunities for analytics and machine learning, which had not been previously possible. In short, the company was able to scale up. They were able to process with greater flexibility. They had increased opportunities for extensibility as well as integration with other services, other other components and projects that were available to them that were not available previously in their non-cloud infrastructure, with a significant financial savings. And as something that we've talked a little bit about billing, they were also able to get accurate cost center data. So a lot of companies, they will have chargebacks. I'm sure you know this. They want to basically have departments pay for the resources that they consume. And for example, in GCP, you set up a project that represents the business processes for a particular department. Billing is done at that level. You have incredible insight into how departments are spending their money, how their resources are being used. It also yields opportunities for re-architecture for maybe projects that aren't necessarily doing so well. Maybe they have adopted more of a lift and shift approach. The billing will reflect that. And so that gives the ability for executives and teams the ability to hone in and address that situation. So this is a sanitized version of that infrastructure. It looks similar to the other one that we showed earlier. It's a data processing pipeline, but we have our data flow plugging into other microservices, whether they're standalone cloud functions or using microservices in containerized fashion, etc. Pumping data into data warehouse type environment for data science and analytics, but then also making it available in cloud storage for other processing possibilities. Analytics takes many forms, not just one. And so once it lands in the cloud storage, we actually have that data being the announcement of that data being available through the enterprise in an event-driven fashion. So interested consumers, departments can, in your real time, pull that data into their systems if they are not leveraging a BigQuery or a relational database on the downstream. So this allowed them to, like we said, to meet their scalable concerns. They were able to grow along with the success of their business. Their infrastructure did not impede their growth. In fact, it paved the way for growth. Not only did it maintain and increase actually their efficiencies, it provided new opportunities for insights, for use with tools that they couldn't before leverage just because their environment, their existing infrastructure was too viscous. It was too difficult to move things around. It was too, being able to stand up a machine learning environment within that architecture would be prohibitive, not only from a cost perspective, but also from just a data movement perspective. So using a cloud architecture, those barriers are removed. The viscosity is almost non-existent. So I was very proud of this project and the success that it brought to the company. So I would like to now maybe turn this back over to Remy for questions.
Bryce, thank you. That was great. I enjoyed hearing about the viscosity of the data environment and how you were able to free that up. We're now going to turn it over to questions. Again, please ask any questions you may have for Bryce in the questions panel on the right in the GoToWebinar panel. We have a few minutes, so let's start with the first question. Bryce, what is one of the biggest reasons you've seen that cloud projects haven't lived up to their expectations?
Yeah, that's a good question, and it does happen. It's one of the big things that I would say around this is that projects rarely fail due to technical reasons. Most of the times that I have been involved in a project where there wasn't great fanfare at the end of the project was because expectations weren't managed. Realistic expectations weren't set. Different parties, different stakeholders had differing ideas of success. And so one of the biggest one of the things that Caserta does that I really enjoy is being involved with is defining what success looks like up front. So you can measure how you are marching towards that. And it gives stakeholders a great way to see all on the same page. It's like playing chess. I love chess because one of the things about chess is that nothing's hidden. Everything's out there on the board. There's no hidden pieces up the sleeve, hopefully. Same thing with defining what success looks like to all the stakeholders up front. Allows for input of that nature. But some specific reasons could be that I've seen have been more of an inclination for certain departments or companies as a whole to adopt more of a lift and shift mentality, rather than architecting their solution to take advantage of the cloud. It's not just an execution shift. It's not just moving your executables and your data. It is a paradigm shift. It really is. And there's great opportunities to be had in re-architecting.
All right, thank you. We have another question. This one's actually about cost. After we migrated to the cloud, it has actually ended up costing us more money than before. What are some of your recommendations to keep costs down?
Okay. So we touched on some of these during the presentation. And actually the last question also had a component of that. And that I would first start off by saying, is your approach a lift and shift approach? Just because you are now operating on someone else's machines in the cloud doesn't mean you are embracing the cloud way of doing things. There are cost benefits of doing things the cloud way. As mentioned, don't fight the cloud. It won't fight you back. It won't beat you up and rob you if you do things the cloud way. So that is probably point number one. Second is that depending on how the architecture was implemented, it could be that certain implementations of your larger architecture are not as efficient as others. Essentially still hanging on to the lift and shift mentality. Using the project-specific billing is a fantastic way to identify and nip that in the bud as soon as possible. So one of the big components of that is data movement, like we talked about. If you're moving data across certain cloud regions, that can build up. Another big thing is properly securing your environment. I didn't spend enough time talking about service accounts in the GCP platform, but securing your environment against unauthorized access for even things like storage is a great way to keep your costs under control if you maintain an adequate security policy around that.
Okay, great. And that's all the time we have for today. We went just a little bit over. Sorry about that, guys. If you have any further questions you'd like us to answer, please don't hesitate to email me, remy@caserta.com. Again, Bryce, thank you so much for the presentation. I hope everyone enjoyed it, and we'll send you a recording as soon as it's processed. Take care.
Thank you.